LLC. And I'm here today to present on the raw material supply of magnesium Thixomolding chips and the recent commissioning of our magnesium ingot chipper. Unlike high-pressure die casting that utilizes magnesium in ingot form, Thixomolding uses magnesium in chip form, and these chips are similar in size to that of a grain of rice. In terms of an executive summary, we'll be discussing that consumers in the United States now have multiple Thixo chip supply options. Magpro commissioned a new ingot chipper in the first quarter of 2025. This decision was made to start producing chips based off of feedback from consumers and their request to purchase chips directly from a magnesium ingot producer. Today, Magpro is the only domestic magnesium producer of Thixo chips in the United States. We've been selling Thixomolding chips to our consumers in the US for the past 6 months. And based on the positive feedback from those customers, Magpro will be expanding our Thixomolding chip production in order to grow with the industry and ensure no risk of raw material supply interruptions. A quick overview on Magpro. We were established in 2003 and have over 20 years of continual ingot production. Our facility is based in Camden, Tennessee. We are a full-service magnesium recycler specializing in type 1 and non-type 1 magnesium scrap. We are a producer of secondary magnesium alloys for a variety of industries, and we're the only pure magnesium producer in North America. Our production facility is ISO 9001-2015 certified. From a process flow, Magpro begins with the raw material input of class 1 and non-type 1 scrap. It's brought to our processing furnace and then taken to one of 4 casting lines that can produce a variety of ingots in different shapes and sizes. Those magnesium ingots can be directly sent to our inventory or to our new chipper to produce Thixomolding chips. Looking at Thixo chip options, Thixomolders in the United States have the following 3 options when it comes to purchasing magnesium Thixomolding chips. The first option is to utilize a third-party chipper that's located in the United States. In this scenario, the consumer first purchases the magnesium ingot from a domestic or offshore producer. The magnesium ingot is transported to the third-party chipper. The ingot is then converted to a Thixomolding chip based on the availability of that third-party chipper. And finally, the Thixomolding chip is then transported to the consumer. Under this scenario, the consumer must account for additional freight costs, lead time for delivery, the handling of any off-spec chips or ingot butt ends generated by the third party, and finally, the potential to carry additional on-site chip inventory to address any delays during production and transportation. The second option is to purchase chips from an offshore magnesium producer. In this scenario, the magnesium ingot is produced and transported to a third-party chipper. The ingot is converted to a Thixomolding chip and then transported overseas to the consumer in the United States. Under this scenario, the consumer also has to account for additional freight costs, lead time for delivery, and the potential to carry additional on-site chip inventory to address any delays during production. Due to the excess time in transit, there is a risk of the Thixomolding chip being exposed to moisture, resulting in caking and oxidation within the packaging. The third option is where Magpro comes in. This scenario allows for the consumer to purchase the chip directly from the magnesium ingot producer in the United States. This results in reduced lead time for delivery, reduced freight costs, reduced risk of moisture contamination and oxidation, and no off-spec or ingot butt ends for the consumer to deal with. Another advantage of this scenario allows for the consumer to form a closed-loop recycling agreement with Magpro, whereas 100% of the magnesium alloy scrap generated during the Thixomolding process can be recycled back to Magpro where we convert that back to Thixomolding chips. This results in cost savings for the consumer and them no longer having to deal with magnesium in ingot form. Moving on to the commissioning of Magpro's chipper. The commissioning of our ingot chipper began back in the fourth quarter of 2024 with the construction of a new 3,000 square foot building located at our production facility in Tennessee. Following the construction of the building, the ingot chipper was delivered and assembly began. Our chipper is equipped with an automated ingot feeder, as well as a high-powered magnet to capture any ferrous material, and any off-spec chip sizes or ingot butt ends that are generated during this process are simply recycled in-house by Magpro. Here you can see the final product in chip form. These chips are consistent in size and shape, and it meets the requirements of the Thixomolding industry. Our Thixo chips are then loaded into super sacks, where we offer them in a variety of weights, to 1,500 pounds, 2,000 pounds, and custom bag weights are available depending on the consumer's needs. These super sacks are placed on wooden pallets for easy transport to the end user. In summary, Thixo chips are now available by a US magnesium producer, resulting in no offset or ingot butt end waste for the consumer. All scrap types can be tolled back into Thixomolding chips. In order to grow with the industry, Magpro has purchased a second and third shipping machine. Magpro will construct a new 7,500 square foot steel building to hold all three of these ingot chippers. The additional chippers will be installed during the fourth quarter of 2025, and production will be brought online as demand increases. And finally, engineers can now design in magnesium with confidence, knowing that magnesium chip raw material is available from a secure and reliable domestic producer. And with that, I'd like to thank everybody for their time, and I'll turn it back over to Rose.
Okay, thank you so much, Tom. It looks like we have just a couple minutes left. So going into the Q&A panel, Michael just has asked, which process is used to chip the ingots?
Well, the actual chipper is designed to handle a magnesium ingot. So I don't know the specifics, but there are basically circulating teeth that grab the ingot and chip it into form.
Okay. And then it said his second question is, you say 100% recycling loop. That means you have no losses?
No, what I meant by that was any scrap that's generated by the actual Thixomolder, we can process back into a magnesium ingot and then take into our chipper. So things such as class 1 scrap, gates and runners, dross really isn't involved in Thixomolding, any painted scrap, any non-type 1 scrap. So anything the Thixomolder generates, we can process back into an ingot and then into chip.
Okay, thank you so much. Oh, one more. Looks like we have time for one more question. This is from Meridian Lightweight Technologies. Is there different size of chips available?
There are, and we'd be happy to discuss that with Meridian offline. There are ways we can modify the chipping sizes, so we'd be happy to discuss that with you offline, Meridian.
Okay, and from an anonymous attendee, how consistent size/shape of the chips is required for the Thixomolding process?
Well, I'd probably let one of the Thixomolders answer that, but as you saw in our photo, our chips are very consistent in size. And so far, we've been supplying this for the past 6 months. They have worked extremely well with our consumers here in the United States.
Okay, thank you so much, Tom.
Thank you, Rose.
And next, Introducing Marco Tropper from TPI Technology. Marco.
Okay. Hi. Thanks for having me. Great that a lot of people in the webinar. So I would like to speak about Thixomolding on conventional die casting machines. This is what we have developed at TPI, and also in the ending a little bit of the developments in the area of flame-retardant magnesium alloys. From our side, TPI the full name is Thixotropic Piston Injection Technology Limited. Why this name? I will give you the answer a little bit later. It is founded in 2019. We are located in Austria, in the very beautiful Styria. And we are now 21 employees here, located in Austria for R&D and production of modules for the European and US market, and additional 18 people working at LK. LK is one of the biggest die casting machine producers and also investor at TPI. And they are supplying the Asian market with modules. The structure is like that DMS founded together with LK TPI. And as you know, also IDRA is part of LK. And after 5 years of R&D phase, we have suggested to develop for us, we think, industry-changing method to casting magnesium alloys in Thixomolding, due to the fact that with our module, you can go with the module on a cold chamber die casting machine. And so you're very flexible of casting Thixomolding, but also conventional aluminum or magnesium cold chamber die casting. As you know, magnesium is one of the lightest material on Earth from the metal area. And we are thinking that in the future, magnesium has a very bright future. Also regarding the fact that the EV and the aviation business and so on are very pushing more and more into lightweight. There was always questions why magnesium never will be a relevant material. Magnesium is too expensive, magnesium is too dangerous in production, and magnesium has a too big CO2 footprint. First of all, magnesium is already now in China, especially already lower in cost than aluminum per kilogram. Second point, it's too dangerous in production. We are solved it by our TPI technology due to the fact that also in conventional Thixomolding, Thixomolding is a closed process with just-in-time melt preparation, and also flame-retardant alloys are available. And last but not least, the CO2 footprint of magnesium can be lowered due to the fact that TPI only needs electricity to run, so it can be run CO2 neutral. Magnesium can also be get out of seawater, and with modern processes, there can even lower the CO2 emissions regarding or against what was possible in the future, in the past. So back to a little bit of the history of Thixomolding. It was invented at the MIT Institute around in the 1990s. They were seeing that when you turning inside of a magnesium slurry, a ventilator then you can see that the viscosity was expected to stay the same. But due to the fact that the particles got globolytic, the viscosity was going down. And due to that, there was invented the Thixomolding process or the concept of Thixomolding. First of all, it was IP licensing by Thixomat. So out of the MIT Institute, there was founded Thixomat, and they have the patent on it. Due to the fact that they have seen that the dendritic shape of the structure went to the rosettes, to mature rosettes, and then to the globolytic state where Thixomolding is used. And after the licensing or the patent was finished, a lot of different suppliers went into this market and produced Thixomolding modules. We call it, or Thixomolding machines, we call it Thixomolding 1.0. And why still, let's say, nobody is using it? This is because the technology is so new. And due to this fact that we have this webinar today, it's very great to show what Thixomolding can do for you. So our module, we call it Thixomolding 2.0, as you can see it on the screen, is that we putting a module that has a screw inside and bringing the material in the thixotropic state on an existing cold chamber die casting machine to this state. So we have a dosing unit. This is the TPI module. And additional, the cold chamber die casting machine have the clamping unit and the shot unit. So you can do both processes with one machine that can lower your capex. Around 16,000 machines in cold chamber die casting operating. And we are thinking with our technology and our module, we can bring a lot of machines to Thixomolding due to the fact that it's much easier, more suitable, and more flexible for customers. What we are combining, we're combining the plunger system of die casting with the screw system of Thixomolding. So you can see it, and also the nozzle system with the plug. So you can see on the right side, the system move together. We can shoot with the very strong injection unit of a cold chamber die casting machine up to 10 meters per second, and still using a screw on the side to dose the material and bring it in the thixotropic state into the machine. And still the nozzle system that allows you to have a small gating system, also direct in-gating on the part is possible, allows our module too. Coming back to our name, it's thixotropic piston injection. So the T stands for the thixotropic state of the material with low porosity, tight tolerances, and low energy consumption. The P stands for piston with high pressure, no backflow like in a check valve system in conventional Thixomolding, and more cost efficient due to the fact that the pistons are much less expensive than a screw to change during shots. And the injection system with the nozzle system, you can do direct in-gating on it, have less secondary material, and a closed process for safety. This is a reference layout from one of our customers. You see on the top the TPI module standing beside the die casting machine. It's connected with the TPI platen, with this TPI platen to the basic machine. And here it was a 1,600 ton machine with 3 kilogram shot weight. And still, you always have the possibility that the holding furnace of aluminum or magnesium can stand beside your cold chamber die casting machine all the time. Here's a little bit of sketch of our system. So how you put the TPI module on your core chamber die casting machine. You have your fixed machine platen. You put the TPI system with the TPI plunger and shot sleeve on your machine. In the middle is the TPI platen, we call it. It's an intermediate platen between your tool and the fixed machine platen. And you need it because you have to mount our system, the screw and the shot sleeve together, and it have to kept tight here in the front. And on the lower side, you can see here the screw tip that is closing here in the front. So you have to understand, against conventional Thixomolding, we never shoot with the screw. We always shoot with the plunger, and during the shot, we are moving forward with the screw, and with the screw tip, we're closing the screw and the barrel system. And we can go up by this to 1000 bars because the intensification pressure comes from the core chamber die casting machine, and we have no backflows due to a check valve or something like that. And to dose the material, in the end, the material is between 580 and 630 degrees hot. These are the different steps. I will go a little bit faster. It's not so much time. Last part, holding pressure is on it. The cooling starts. The screw moving backwards. We open the valve. The screw is turning, bring the material into the shot sleeve. The shot sleeve is all of the time 100% filled up, so there's no air inside or oxidation. And at the same time, the screw is turning and bring the material into the shot sleeve. The plunge is moving backwards. Then the screw moving forward. We're closing the screw tip. The plunger is in the back. The mold opens due to the fact that we have in the front a plug. No material can flow out. The parts get ejected. The mold closes and the next injection is done, and the holding pressure is again on the next part. This shows a casting part we cast in our test center. It's with direct ingating. So no biscuit, no big runners, and less waste. This is our series, our first one, the Super Blast, with you can go on die casting machines around between 700 and 2,500 tons with different screws regarding the parts you want to cast. A lot of Thixo products will come in the future. So we have already cast steering wheels, brackets, IC boxes, light structure, and so on and so on. And here you can see in a very fast video our TPI system. During the shot, the screw is turning inside, moving forward, closes. The parts get ejected. The robot put it out of the test center, spraying. The machine closes again, and the next shot is done. And shot. So we have in Austria the 900-ton machine in the test center, and we really appreciate it if you have products and projects. You can come to us. We are casting parts for you free of charge, and you can see if you are happy with the system or not. And also, beside TPI, there is the DMS, the company above TPI. We are doing their filling simulation and gating design, so we can also help you there. At LK, China Ningbo, we have a 1,600-ton machine, also with the TPI Super Blast on a bigger machine. This is our machines in Europe at customer sites. You can see we have already sold several machines in the market. And this is our biggest development, the Gigablast. The target is with one screw on one side, 20 kilograms, and both screws 40 kilograms for machines from 4,000 to 7,000 tons. These are different machines: Microblast, Superblast, Gigablast, and Dreamblast. So if you're interested, always can come to me. And for magnesium carbonate, there is no big time anymore. But together with Core 12, we have developed magnesium carbonate. So it's an inherent flame retarded alloy, and it's around 10% more strength than traditional AZ91 or AM60. Also, there is carbon powder inside that hires again the values of the material. And if you're interested in this flame retarding alloy for aviation business, e-bikes and so on, please feel free to go at info@core12.co. Thank you very much.
Okay, Marco, it looks like we have a couple questions. Thank you very much for your presentation. From the webinar chat, somebody asked, does it require any inert gas or cover gas?
This was one of the goals of the development. TPI was developed due a subsidy project of the Austrian government too, together with LK. We only need the covering gas in the startup of the production when the short sleeve is empty, but when the short sleeve is filled up and the plunger at the piston is sealed, then you can turn down the argon gas or the inert gas, so you can, during production, during serial production, you do not need it.
Okay, then next question. Marco, can you share some experience of users of the module about switching between aluminum and magnesium chips?
Aluminium Thixomolding is on our agenda to do it. Maybe it was asking to switch different materials from switching from AZ91 to AM60, for example. It's quite easy. We have done analysis. So with a D100 millimeter screw system, after 50 shots, the material is changed. And if you mean to switch from aluminum cold chamber die casting to magnesium Thixomolding, it needs around 6 hours to put away the TPI module, and you can do aluminum die casting again.
Okay. Also from the Q&A, how about the integration of the module in the machine controller?
We have internally software engineers that doing this all the time. So right now we have already connections with IDRA, LK, Frech Machines, Bühler, and so on and so on. So we are open to every die casting machine, and the integration is part of our service.
Thank you. Okay, how precisely are the temperature and hence the solid fraction controlled within the barrel?
The temperature is in a little range. We have PID controllers. I would say the range is around 3% plus minus of the temperature you set inside of the machine. When you have a lot of stops of the machine, the temperature is pending a little bit. But when you're in serial production, it's quite all of the time the same. And you can set on your machine how much solid particles you want to have inside of your part due to the fact you can change the temperature.
Okay. We do have a lot of questions for you, and they're still coming in. So here's just a reminder to any attendees. The Q&A portion, it's on the menu at the bottom of your screen. You'll see a little box where it says Q&A, and that is where you can submit questions. We most likely won't have time for the presenters live to answer each question, but they may be able to type answer if they do choose so and have the time. Thank you so much, Marco.
Thank you.
Okay, and now introducing our next presenters. We have Minhyuk Lee and Takashi Uyabu from the Japan Steelworks Ltd.
Yeah, thank you very much, Rose. And hello, everyone. Yeah, I'm Minhyuk Lee, the overseas sales representative at JSW.
And hello, I'm Takashi Oyabu, and I'm also in charge of the sales of JSW magnesium Thixomolding machines. Nice to meet you.
And please give me some time to share my slides. Wait a second, please. Okay, so are there any problem? If not, yeah, please, yeah, let me start my presentation. So, good morning, good afternoon, good night, everyone. Yeah, please let me introduce one more time. My name is Minhyuk Lee. Yeah, and I am the overseas sales representative at JSW, Thixomolding Machine Department. And when I usually have these kinds of presentation, I usually have to start like, even like what is magnesium and like what is Thixomolding. So it is really pleasure to be talking to you guys who already know basics. Yeah. So thank you very much for taking the time to join us. If you have any questions in my presentation, please ask me after the presentation. Okay, let's start. And here is index of my today's presentation. And first part is basic explanation about Thixomolding machine and our role in this supply chain. Yeah, as you guys already know, JSW develops, produces, and supplies the magnesium Thixomolding machine. We have these 5 models, which is distinguished by their clamping force. And you can check the features of the Thixomolding machine in next slide. So in contrast to die casting, it has high safety and environmental performance. The molding by this machine can be performed just like a plastic injection molding machine. So it doesn't have melting furnace, so it doesn't need to use kinds of cover gases. We can say it as flame retardant gases, which is harmful to the human body and equipment both. So it doesn't produce any dross or sludge, so we can have safe and clean working environment. On top of that, we can start up it quickly and also safe shutdown and easy maintenance too. Next, let's see a table shows the specification of each models and examples of molded products. As you have bigger model, you can produce bigger products. Please refer to the slide. And let's move to the structure of our Thixomolding machine. I recognize that there are some differences between the machine named Thixomolding machine, so I would like to show our machine structure. It's almost same with the plastic injection molding machine, but the material of its screw and barrel is different. We use materials which can bear until 630 degrees Celsius. So we put magnesium chips by this hopper and let them move forward while hitting them in this barrel. And finally, we can inject them into the mold. And next, please let me introduce about our support system. Yeah, we provide production of prototypes and mass-produced products too. And also, we also provide evaluation support like physical properties evaluation and prototyping. Also, we support model selection and flow analysis and molding machine troubleshooting too. Please refer these slides. And next, please let me introduce about our group company named MG Precision, and we can call it just MGP, which has established it in 1996. So this company produces their products using our Thixomolding machine. Next slides, we can see the equipments they have. They have these four motors machine and another machine equipment and chemical conversion, painting too. And let's move on to the recent efforts to the development. I can say the development of high temperature screw cylinder for AM50 materials can be a good example of our recent effort. Our purpose of this development is for steering wheel and cross car beam. Not only about the machinery, but we also conduct research about the new application of alloys. Recently, we are conducting the research about the application of magnesium lithium alloys to Thixomolding machine. In this case, we also do the make of connection between our user and the alloy supplier by our existing business partners. Let's go back to our machine models. We have developed 1300 motor and 3000 motor machine recently, and now we are heading to our next motor, 1800-ton machine. We have begun development of this 1800-ton motor and hope to introduce it to our customers in the near future. Also, we are considering develop next bigger motor like 4,000 ton. However, it's also true that we can't be assured to decide whether the market is wanting the bigger Thixomolding machine motor. Otherwise, next machine with more developed technology. So now we are on the strategic evaluation to determine optimal direction. Next, let's move on to the opportunities in adopting our Thixomolding machine. Now we are monitoring the possibility of application to aerospace industry too. I mean, we already found some of our customer is supplying their products to one of the biggest global company in the aerospace industry. The automotive industry has been going through a tough time lately, but this new industry we've discovered is pretty exciting for us. However, we recognize that this is still an early stage. It is crucial that we approach this opportunity with careful consideration and thorough research. We are currently evaluating the potential of this industry, and we aim to develop a strategic approach that aligns with both our capabilities and long-term goals. So, today I'll be truly happy if I can get any new insight about the application to aerospace of Thixomolding technology from you guys. Yeah, this is the end of my presentation. Thank you very much for listening.
Thank you very much.
Thank you.
So a question from the audience. What is the temperature range used for magnesium thixomolding? And what is the maximum and minimum solid fraction you found?
Firstly, the maximum temperature of our machine is currently 630 degrees in Celsius. So the range, I think it's it's different at each stage, but like from like 200 and 300, and then until like 600 degree. Yeah.
Okay, next question. For JSW, are the larger tonnage machines a twin screw or a single screw system?
It's twin screw, right? Oyabu-san?
Yeah. Basically, our 3,000 ton is for single screw and cylinder, but we have the special one and the special one with twin screw and cylinder. And after we receive the product information, we will decide which one is better.
Thank you.
Mhm.
Okay. How do you rate the market developments from China, which advertise 17 to 20 kg shot weight with 5,000 machines?
Can I hear one more time, please?
Yes. How do you rate the market developments from China, which advertise 17 to 20 kg shot weight with 5,000 machines?
Yeah, basically, yeah, we raise, Chinese technical development is pretty, how can I say, yeah, threatening to us. Yeah, recent development is really, yeah, amazing. So, but I don't have any idea about, the specific, technology, but basically we, yeah, recently, consider is truly, yeah, threatening for us.
Okay, looks like there's not any more questions right now, but if there are, please feel free, audience, once again, to submit a question using the Q&A button at the bottom of your screen. And if the presenters have an answer for you, they may type back to you. Okay, thank you very much for your presentation today.
Thank you very
And
much.
Thank you.
now moving on to our next speakers, which are Angus Liang and Scott Burkett from Yizumi. Or if Scott and Angus, are you there?
Scott is.
There we go. Take it away.
So I'm just here to talk about where this market's going. And actually, I see it as lightweighting 2.0. Back in the 90s, the early 2000s, we replaced steel with aluminum. And that was mainly across the board into, some gas and oil, some military, but mostly automotive and medical. In the 90s, we tried Thixomolding. We tried a process called reel casting or semi-solid, which is done with aluminum. The two key advantages of Thixomolding and reel casting is you can get really, really thick walls and really, really thin walls. In fact, the thin walls, those numbers are being pushed to their limits and they keep getting thinner and thinner. But in the early 2000s, I was a young service engineer. I could manipulate a machine however I wanted. But one day I'm having breakfast with a guy you guys might know, Bob Powell, GM Tech Center. We were down at Gibbs Die Casting, and he explained to me that I think the number was like every 72 pounds you take out of a car, you get 1 mile more per gallon. But then he also talked about weight below the axle. All that weight you can get out changes your ride comfort. If you look at the weight of a new Tesla, it's heavier than my F-150. They need to get the weight out of these vehicles, and the only way to do it is going to be magnesium and some reel casting with aluminum semi-solid. But we no longer have the royalties that we got to pay for. Looks like materials becoming more available in the industry. But even the big parts Tesla makes over in California and in Texas, the big giga castings, those parts are now coming out of China in magnesium. Angus is going to have some pictures of some castings. Yeah, in the 90s, we made some transmission housings, some engine blocks, all made of magnesium. They didn't go anywhere because of the supply and the demand and the cost. But Thixomolding, the machines are getting bigger, a lot bigger. And truly, mag is the only way we're going to lightweight some parts. This is a converted die casting part out of China. As you can see, it's Thixomolded. It's an electric vehicle housing. And, the more weight they can take out of these vehicles, these electric vehicles, the better mileage they're going to get per charge. I mean, talk to most Americans. The big problem with electric is how far I can go. And that needs to change. Here's actually another part. Actually, there's a steel insert race in here for this electric vehicle housing. And you can see your scrap or your runner's only going to be a little bit on these converted parts. Could these be made thinner walls? Yes. But these were just trials to change the part from aluminum to mag. So everybody, I think this is here to stay this time. This isn't going to be like the 80s or the 90s and the 2000s. Yeah, I guess keep your eye on Thixomolding. And it's everywhere. It's military, it's space, auto, medical, gas and oil, computers, it's everywhere. It's going to be a new process in this world. One that worked well before, and I think will work better today. That's about all I got. Angus is going to show all the big parts that we're making.
Angus, you're on mute. Can you unmute your audio?
Can you hear me?
Yes,
Yes,
we can
now
hear
we
you
can hear
now.
you.
Hello? Can you hear me?
Hi. Yep.
You can. Okay. All right, just let me quickly go through the presentation. Okay, so hi everyone. My name's Angus, and I'm from Yizumi, and I'm responsible for the sales of Thixomolding globally. And thanks for IMA giving us a chance to be able to have a platform to talk about magnesium and also Thixomolding processes. Of course, today we don't have much time to talk about detailed content. So if you have any questions, please feel free to send me message or emails to this email address. So just quickly to introduce Yizumi. So we are a Chinese company. So we do different machines, started die casting and Thixomolding. We produce over 1,200 machines per year. And then we do injection molding, one of our biggest business, which is 15,000 units per year in producing. And then we also do rubber injection molding and high-speed packaging. And also our Yizumi Germany colleagues doing 3D printing solutions. So basically we established 2002, and so we're still a very young company. And by the 2024 financial statements or reports, we generated 5.6 billion revenue in Chinese yuan, roughly around 610 million. So compared to 2023, we have over 23% growth. And like always, we spend 5% of the revenue every year to our R&D development. And our export share roughly is 25%. And we have employees globally around 4,500. And like always, we try to be the industry best cost-effective solution provider with leading technologies. This is our goal and target. And just quickly, this is our global layout. We have over 700,000 square meters global production base, and we have roughly 12 overseas subsidiaries, including Germany, United States, Mexico, etc., right? Indian. And we also have been established like recently in building, right? And I think Italy is nearly ready. And then Hungary and Mexico second plant. And we cover over 70 countries and regions. And within this 4,500 above staff, we have 800 engineers and specialists. And I would like to talk about a bit more of the benefit and challenge of Thixomolding, since a lot of presenters already show the process of how it works, right? So we have found out this process have laminar filling, which will lead of reduced porosities. And because of this reduced porosities, we're able to have a better mechanical properties and also better leak tightness. For example, if you are using these parts for gas, you know, and then we have higher surface quality for coating and weldable and heat treatable because you have very little porosities, right? And we also have a lower metal processing temperature, which is able to reduce our energy consumption. We actually have a case story that we have a customer comparing the hot chamber die casting, and overall we have 50% roughly, right, energy saving Thixomolding compared to a hot chamber. And we definitely have extended die life compared to die casting because of this lower temperature and no injection speed, and lower shrinkage, which have impact on we are able to do low draft angles and to do high wall thickness variations, minimal wrapping, and tighten tolerances, and be able to reduce rig works because of such precise dimensions. And we also have higher safety and better sustainability. Basically, nothing is exposure to the air. Everything's happened inside the barrel, right? And then we don't use any protective gas at all from the beginning to the end, no? So mainly the challenges, right? Since nowadays we don't have many, well, compared to die casting and injection molding, right? We don't have many users in the market. So process management is very sensitive and limited industrial know-how regards to Thixomolding processes. So that requires very good trainings to our customer. And in the past, I mean, limited part size are one of the challenges and the weight and machines, but it seems not anymore, right? By tomorrow, during the Shanghai exhibition, we will release the latest tonnage of Yizumi for Thixomolding, what we can do. It goes up about 5,000 tons, you know. And in regards to the metal prices, I think in the last 2 years, the fluctuation is quite big. But recently, it's quite stable since a lot of national enterprise, we talked about China, right, have entered this market and trying to stabilize it. So what happened in China at the moment is not even not just light metal. It's always because the magnesium price is actually cheaper than aluminum. That makes a lot of OEM coming over to our company to do trial casting because we have machine in-house, right, to do trial casting and trying to convert from aluminum to magnesium also. And this would be most of the important part, I would say, for Yizumi, what we can do for our customer. So we're not just a machine builder, you know. We actually can be able to customer from the scratch, try to minimize the risk, right? We started for the material evaluation for the customer, doing test bar casting, treatment, all kinds of testing of mechanical property, etc. And after that, we will generate the test report for our customer. After that, we're able to look into the product, like the product design and adjustment of the design. If the customer in the past used plastic for this part or aluminum, we're able to help to convert to magnesium, right? And after that, we do part simulation, etc., to be able to confirm to the customer, yes, this part is able to do Thixomolding. And later, we are able to do the detailed mold design and manufacturing and be able to do sample casting for our customer to send it over to the end user, right, to see if they're able to meet the final customer's requirements. So this would be very important for us to help our customer. And these are recently some projects, trial casting happening in China, which the OEM or some potential customer came over to do the testing. As you can see, most of them are 2,000 ton and 3,200 ton. And they mainly do mortar housing, thick wall casting in China, not thin wall. And we are able to help them to do X-ray scanning to see whether there are any defects, porosity, etc. I think at the end, most of the parts came with a good result, And for Yizumi, we also developed Thixomolding into a few aspects. Started with process technologies like multiple hot runner system. As you can see here, the picture. This is a
Angus,
hot runner system, multiple hot runner system we also developed. And for machine sizes, as I said, we'll release a machine tonnage over 5,000 ton tomorrow. And part surface treatment. So as we also aware, magnesium exposure to the air, this would have corrosion, etc. So we're actually cooperating with institution in China to test such like oxidization, right? And the research in electrochemical surface treatments. So that result in a good result, right, in regards to this application on exterior parts. If you want to know more about it, send me emails, I will be able to get a specialist to answer you questions. And the last one is the process simulation. So we actually cooperating with software partner like Magpro in order to develop simulation, which I will show you in the later pages in details. So basically we do simulation and then we do actual casting and then we do comparison with the simulation and the actual casting and to find out whether the simulation we have done are proper. Okay.
Angus,
This
can you
is
hear
just
me?
one of the example, just quickly to show you the simulation results.
We can't see your screen right
I will
now.
just stop at some point for the simulation.
Yeah, Angus, she can't see your screen.
So, okay, so basically this is the parameter setting we have input into the machine, and compared to the actual casting, this is quite identical, I would say. This is just one of the example. And of course, again, if you want to know more about it, send me emails. And this is the code flow we found from the actual part and the simulation. Hang on. Just a second. Yes. And then this is another simulation we have done for, this is kind of big part, car door frame, with multiple hot runner. And just quickly to wrap up, Rose, I will be finishing 1 minute or two. So these projects we have done in GTK in Germany. So they have a Bühler casting machine, our Thixomolding, and a Frag hot chamber machine. So basically, they do all kinds of R&D development and in between these processes. And we have our Germany colleagues also involved deeply in these testing and R&D developments. Cost simulation, we also did because since we have so many different processes involved, right? We also do hot chamber, cold chamber, and Thixomolding. We generated formulas or a concept of how to help the customer to do calculation. But of course, this needs a lot of real-life example to support this. This reference of our US customer MMP, they have our 1250-ton machine and do 12 safety seats and other different parts, right? And another customer in the US, Bole, also our customer, to do military parts. So I don't have the picture basically because it's confidential. So I think that's all, Thanks for listening.
Thank you very much, Angus and Scott. Doesn't look
Any
like
questions?
we don't have enough time right now to answer the questions
sorry, Rose,
out loud.
I don't think I can hear it. Hang on.
Can anyone else hear me? Andrew?
Yep. I
Okay.
think some things with his audio there, so I'll respond in the chat.
Okay.
I can hear you now. Sorry. Yes.
So, if there are any questions in the Q&A, please feel free to answer them with typing, Angus and Scott. But for now, we have to move on to the next presentation to keep with timing.
Sure. Yeah, so if
Thank you.
you have any questions, send me emails. Thank you.
Thank you very much. Okay, next for our last speaker today, introducing Timo Gunzel from Bole Intelligent Machinery.
Hi guys, I'm a last speaker. My name is Timo Gunzel. I'm the CTO of the company Bole. We produce plastic injection molding machines and also Thixomolding machines. You see my screen? Is all fine?
Yes.
Okay. Yeah, we mean that Thixomolding will make a revolution, especially in the lightweight structure components industry. So, and I want to present what we think and what we do at the moment. When you see the process, we have discussed about right now many things. This is the thixotropic process. We bring the material to a transition temperature, and then we steering or slurring these material that you can do with aluminum and rail casting. This is very simple. You do it in a ladle, but when you do magnesium in a ladle and want to make a slurry, that is very dangerous based on the temperature. And here we use in the end the screw for make a slurry in the end. What Marco explained right now with the transport of the chips from the feeding zone along the screw to the front area, we change from the dendrite status to the globular status. Here you see on the right side the chart. I mean, it was a question in the meeting to the temperature and the solid chair. You see, when you have an ACID 91 and have maybe a run with a temperature of 595 degrees, then you have around 50% solid chair inside. When you run the same material ACID 91 with 580, then you have around 38% solid chair. That means you can say when you have AM60, that is the temperature ranges then plus, so 20 degrees. And when you have AM50, then you have plus 30 degrees. And then you have nearly the same results. That is what we have. So, and normally you run in the Thixomolding process between 15 and 20% solid chair. But when you run the machine with 600 degrees, then it's a solid chair with ACID 91 nearly zero. That we have to take care that we run really below 600 degrees, the ACID 91. So what we have discussed right now, we have a chips, we bring it in the feeder, the screw turns, and we bring the chips along the screw to the front area. And based on that, we build in the middle an oxygen barrier. That means based on this oxygen barrier, we don't need safety gas that we discuss right now in the group here. So, and when we have a lot of material in front of the check valve, then we press the screw back to the position what we want to have for the shot. The accuracy is plus minus 0.1 millimeter. That means our dosing or our shot accuracy is plus minus 0.05%. When you see that in die casting, we discuss about plus minus 1% or plus minus 2%. That means the Thixomolding process is very precise. So also the speed in the Thixomolding technology, when we move forward, with a screw is very less against die casting. When you see die casting, the guys run between 5,000 millimeter, sometimes to 8,000 millimeter. We run normally between 2,200 millimeter per second to 3,300 millimeter per second. That is depends on the semi-solid fraction. Thixotropy means when you have a semi-solid material and bring friction on that material, then you can reach a longer flowway. That is the principle of the thixotropy. That means on a Thixomolding machine, you can have longer flowways with lower wall thickness, and you need not so much speed. That means our experience is you can have a ratio flowway to wall thickness around 400 to 1. That means when you have a wall thickness of 2 millimeter, then you can have a flowway from an injection point to the end of the part of 800 millimeter. So what is the history short? Why is Thixomolding comes to the revolution now? When you see Thixomolding is all technology. What was the problem? This was a patent situation in the past, and we have two suppliers in the end in the world. That was Japan Steel Steelworks and Husky. Husky stops 2009 all activities. JSW concentrate fully of the electronic parts. The guys are very successful with that. But the problem was in the past that it gives only machines with a clamping force of 1,000 tons and a shot weight of 1 kilogram. That means you can run 650 gram parts. That was for the technical parts industry and automotive, not a solution. And that was the reason that Thixomolding comes never really in the automotive or in other industries. It was only in the electronic industry. So what was then the dynamic now? Yizumi starts 2019 right now with a 1,200 ton machine with a 100 millimeter screw. Then JSW increase the screw diameter. Then comes Bole on the table. We built a 1,650 ton machine with a 135 millimeter screw. And at the moment, is a status from Bole. We have a 5,000 ton machine with 22 kilogram shot weight with a 190 millimeter screw. And that brings a huge dynamic in the market that you can now also realize with the Thixomolding process, huge shot weights. So that is our line. We have a small one, a 130 ton, and the biggest one is a 7,000 ton. And you see here also what is our view. We see we will have, so 2026, we will have 70 kilogram shot weight. At the moment, we work on that screw with 48 millimeter shot weight. That comes latest start next year with a 7,000 ton machines together. So, and that we have discussed right now why we do magnesium. Magnesium is a lightweight material and the CO2 footprint is better as aluminum. Clear is for us is magnesium is a never-ending material in the world. You see, when you see how we can produce magnesium in the world, this is a never-ending material. And that is one of the biggest points for us to invest in such technology. Then, of course, it gives a strategy in China to reduce the weight of the cars. Here comes also more and more magnesium inside the cars. We expect that in 2030, we have 45 kilograms right now magnesium in the cars. That means we need a lot of machines in the market. That we have discussed also right now when you exactly see the price situation at the moment between aluminum and magnesium. Magnesium is from the price lower as aluminum, and when you have the same parts, then is magnesium 33% lighter. That means the cost reduction is at the moment 40%, and that sees the Chinese car maker, and these guys invest a lot in these technology. So energy consumption, Angus have discussed it right now. We have measurements that the energy consumption of the 4,000 ton from us is 0.46 kWh per kilogram. When you see a 4,000-ton die casting machine, you have 1.18 kW per kilogram. That means this is more than the half the difference on that have a huge impact. And also when you see a Thixomolding machine on the weekend, when you have no production, you can shut off the machine completely and start on Monday again. Nobody can do it with a die casting machine. Cost reduction, when we calculate die casting, magnesium die casting against Thixomolding, you can calculate it up and down. You find all the time a difference of 20% cost reduction with a Thixomolding machine. So what are the industries for us? Of course, automotive, sports industry, electronic, aerospace. That's are the typical parts which we discuss and produce at the moment in automotive and electronic. Of course, fitness industry, sports, aerospace, Angus have explained right now, it gives a lot of projects in this area. But we have also to look to tools. Tools is also big market for that. And here, for example, we see on the right side a tool for the fishing industry. Here we produce small parts in Thixomolding. So that is in the end our 4,000-ton machine, what we built, and this machine runs right now in production. This machine have a 170 millimeter screw. You see also we are the company which built Thixomolding based on two-platen machine. So that, I mean a big advance in the future when you want to replace a die casting machine. The short end from a die casting machine is very short. At the clamping unit is a toggle normally. In Thixomolding is a injection unit very long, and we need here a very short clamping unit. That was the reason that we go to the two-platen technology to reduce in the end the length of the machine, that the customer can really replace the machine on the same place what the customer have in the end, the die casting machine. So then we produce magnesium housings. That is also on our 3,000-ton magnesium housing production of a 3,000-ton is works on our machine. You see here, full automatic is it engine housing. That is one of the mega trends in the industry in China at the moment. Many guys want to reduce the weight of the components. You see here that is engine housing in the air. On a 3,000-ton machine with a 170 millimeter screw. So, and we are the one which produce wheels, 20-inch wheels, on the 3,000-ton machine with a 190 millimeter screw. And that is at the moment a huge project in the industry, wheels. And here we have also a video. When you want to see that, I can send it to you. Based on the time, I speed up a little bit. So what is one of the mega points is we invest also in material development. We make a lot of material developments for better thermal conductivity, for better strength, for better corrosion resistance. That is one of the biggest points, especially for outside car parts. So recycling is our point. We have found out that you can make a direct recycling for the sprues and overflows. You cut it, bring it back to the Thixomolding screw, and have the same result. When you see the number 313 is without recycling material, the 370 is with recycling material. That means the property is the same. That means the customer have a closed loop material recycling process. And of course, we have a hot runner running right now. That is one of the mega trends. We want to reduce in the end the short weights. That means in the future, we won't not have any more sprues and overflows. That is the strategy. And we won't run without flash. That is the strategy from us, that we in the future run without flash. That is our opportunities, what we have. We have 300 tons in the lab, 700 tons in the lab, 1,650 tons in the lab, 2,000 ton and the 3,000 ton. And end of the year, we have a 5,000 ton in the lab for test parts for the customer. And we make some test trials, a lot of test trials. So I hope I am in time, Rose.
Yes, you're perfect
Good.
on time.
I have speed
And
up a little bit, but good was that many guys have present right now many things about Thixomolding.
yes, it was very nice. And we do have time just for a couple questions, if you'd like. So the first question is, what cycle time is possible with the 5,000 ton machine at 22 kilogram shot weight?
This depends on the wall thickness of the parts, but we expect that we can run between 90 seconds and 2 minutes. Depends on the wall thickness. When you have a structure form parts with a wall thickness 2.5 millimeter, you can also run in 60 seconds, but you will never have them 22 kilograms. You have them maybe 15 kilograms.
Thank you. Another question. For Bole, how many 3,000 ton machines are currently in production worldwide? Do you see a recent uptick in interest recently?
We have running at the moment 3 machines. I have seen that the JSW have also 4. I don't know what Yizumi have, but we have an order right now, additional 3 machines, 3,000 tons. And I expect that we have maybe in the market, I expect so next year minimum 20 machines. What we see from the project view at the moment.
Okay. And then who produces the shown subframe in Thixo casting in series production?
Which one? The frame. Which
The
part?
subframe. The subframe. It says the shown subframe in Thixo casting series production. Maybe you can address.
That is a prototype. That is a prototype. Yeah. That is not in series at the moment. When you see most of the parts, what at the moment comes in Thixomolding is test and try parts. We have running at the moment around 25 machines in series production, but that is mostly parts which we deliver last year right now. The parts what we at the moment deliver, maybe the wheels or the engine housing and so on, comes, I expect, the next year in series production. You know, so the automotive industry needs time. The China speed is faster than the European speed, but these guys need also 24 months at the moment.
Okay, thank you so much, Timo. Any other questions in the Q&A? You may answer if you can through the typing.
Send me an email or send to Rose an email and I answer the question.
Okay, great, thank you. Okay, that concludes our webinar for today. In the coming days, we will have a recording of the webinar up on the IMA website. As a registrant, you will receive an email from the IMA informing you once it's available. It was great to see such a big turnout for our webinar today, and thank you so much for joining us.